notes section to 5.5, nonlinear systems of equations. Nonlinear systems have at least one of the equations that's not a line. You can't have a line in it, but there's at least one thing in the system of the other equations that's not linear. So on example 1, you'll see that we have a parabola, and I know it's a parabola because y is to the first and x is to the second. That's always the clues we look for a parabola. Only one of the variables is squared. And then the other equation is a linear equation, x plus y. X to the first, y to the first, those are our lines. So first of all, I just wanted you to see a picture of that to show how you would solve that graphically. The parabola, just focusing on it first, x squared minus y equals 4. I want to get it in y equals form. It is y to the first, so I threw that across the line, made that positive y. The 4 the other way, made that minus 4. Kind of reading it backwards, so let's write it like this. Y, or f of x, equals x squared minus 4. That is our old parabola, our function parabola, pulled down 4 units. X squared is the vertical parabola, pulled down 4 places, so that's this picture. Number 2, the line x plus y is -2. I solved it for y through the x across the line, and now it's in its function notation. And you can see the y equals mx plus b form. It has a slope of -1 and a y-intercept at -2. So we started our y-intercept of -2, which I've dotted here. The slope is understood to be a -1 over +1. So that means from my y-intercept, down 1, right 1. Connect those dots. And if you're real careful and using a straight edge and you graph it just perfectly on your graph paper, you can tell the intersecting places, and that's your solution. Remember, the solution to a system is where the two graphs overlap, where they run into each other and they share a solution. So one of those points was over 1 and down 3. We can verify that that is truly a solution. It should work in both equations. So 1 squared minus -3 for y equals 4. That checks out. In the second equation, 1 for x and -3 for y would be 1 plus -3 equals -2, and that is true. If it's a solution, it should work back in both equations. So that's one answer. The other answer, the intersecting point, -2, 0, I want to verify that as well, show you how to check that. So -2 for x, 0 for y. So -2 squared minus 0 equals 4. That's 4 minus 0 is 4. That's true. And then checking it in the second equation, -2 for x plus y is 0 equals -2. It's true for that one as well. Okay, so 2 solutions. So that's finding it graphically. And I think I mentioned to you all on Monday that we had redesigned the final exams where you could use graphing calculators if you would like on that exam. So if you would want to do it on your graphing calculator, you would do exactly what I did here. You need to solve each equation for y. Get y equals x squared minus 4. Type that into your y1 function, and then solve the second one for y as we did here. Type that in, hit graph, and then it would do this for you. And then you would look for the 2 intersecting places. And Cheney and I can talk to you individually if you want to look at your graphing calculator for that. All right, I want to show you also how you could do this with the other methods. Without the graphing methods, we have the algebraic methods, like you did on your 5-1 homework. We have the addition method and substitution method. So let's see, this is following along in my notes. The next thing I did in my notes was substitution. So what I've done is I solved this second equation for a variable. Remember substitution, you solve for one of the variables and sub that expression back into the other equation. So following along with my notes, I solved this equation for y. So I made it y equals through the x across the line. And then I subbed that in for y in the other equation. So it'd be x squared minus, instead of y, I'll have -x minus 2 equals 4. And that gets it into just terms of the same variable, so it's solvable. Distribute that negative sign, and that makes it plus x and plus 2. Now I can see it is a quadratic, so I put quadratics in standard form. Once you get your quadratic in standard form, you can either use the quadratic formula or factoring. This factors into x plus 2, x minus 1. Once you get it factored, you set each factor equal to 0 and solve each part. So we get an x solution of 2 and 1. Now don't get in a hurry and think that is your point. Those are both x values, so we need to go back and pick up the y parts to it, the coordinate. So x is -2, and we can see this on our graph. We had an x value of -2 and an x value of +1 where we found the solutions. So, but anyway, that's just the x part. We need now the y corresponding parts. So we do it individually. We take our -2 and go back and look for its y, which you can use either equation. You should get the same result. I'm going to use the linear equation. It just looks a little easier to work with. I guess I could have used it right there. Anyway, now that I know x is -2 is one of the solutions, solve that for y. Plus 2, we get y is 0. So when I plug in x is -2, the y corresponding value is 0. So one of the solutions is -2 and 0. Then get the coordinate that goes with 1. When x is 1, do it again. 1 plus what equals -2. Together it's y value. We throw the 1 across the line. Y equals -3. So when x is 1, its buddy is -3. It's paired. So 1, -3, just the same old thing we knew from this graphing method. Right. So that's substitution. I want to go through this with the addition method just so you can see each method, how to use it, remind you. And I think naturally, I tend to go with that method most of the time. It seems like that's, maybe I'm in the habit of doing that. But when I look at these two equations, that's what kind of pops in my brain as the first method to use anyway, because if I add straight down, those are just set up nicely for y's to add out. So I would probably naturally lean towards the elimination or addition method. Okay, but watch closely. If you use the addition method, because this is x squared and this is x, this takes our mind way back to a fundamental algebra question. Adding x squared and x will give you x squared plus x. They don't actually add together very well because they're not like exponents. So you just have to say that's x squared plus x. And then the y's drop out. 4 minus 2 is 2. And there's that quadratic equation again, so it becomes the same problem we just worked earlier. We get it in standard form, and then we factor and go through our steps as before. We get x is -2, x is 1, and then go pick up the y values like we did before by plugging in -2 for one of the x's. Now listen guys, it doesn't matter because we're looking for the solution that solves this system. So both of those equations it needs to work in. So whichever one we choose, that is your answer. So whether I go up here with the -2 squared minus what is 4, or here -2 plus what is -2, I should get the same result for its buddy, right? And same thing with the 1. All right, so any questions on that? That's really basically it.